So, dear students, hello. So, I will explain today these two things, that the positron emission tomography and the solar panels. I will uh, explain the difference between these two things. Okay. So, what is the positron emission tomography? So, positron emission tomography, that means there is mm, a emission of the positrons uh, from somewhere. So positrons are emitting. So what is the tomography? Tomography, that means the sectioning of tissues and taking the image of that tissues, whether that tissue is normal or abnormal. If there is some abnormal growth, that means doctor will tell you that you have been afflicted with particular type of disease. So to diagnose those disease, to know those disease, use the positron emission tomography. So how uh, it works, the positron emission tomography? So first we section the tissues, and if there are some specific signal, we can say that this particular tissue or organ of that patient has been afflicted with some disease. Okay, so here the mm, tissues are diagnosed, but how to that happen? So actually, the glucose is consumed in the higher amount in case of those organs or those tissues require the higher amount of energy, because glucose is the simplest source of energy. If some organ needs the energy, it will use the glucose more. So if some tissues is consuming the glucose in higher amount, that means they are requiring more energy. So cancerous cells do have this property because they have to multiply again and again, as they are immortal. So those cells will use the glucose in higher amount. But I want to know that whether that tissue really use the higher amount of some glucose. I want to know this fact. So since the radioisotopes can be traced in our tissue, as you know, with the tracer techniques, so in this case, we use a radioisotope of fluorine, that is the F18. F, that is F18, glucose. Okay, so glucose is attached with the F18, and F18 is a radioisotope. However, it seems that it should not be radioisotope, because 9 proton and 9 neutrons must be 18. So that should be atomic weight of the fluorine, but actually it is not. In normal fluorine there are 9 protons and 10 neutrons, but in F18 there are 9 neutrons only instead of 10 neutrons. So this is dissimilar with the normal fluorine. So since glucose is attached with the F18, if glucose is used up by the cancerous cells in higher amount, okay, so F18, the attached F18 will also come to that tissue. But since F18 is a radioisotope and highly unstable, it tries to stabilize itself. So for doing that, since there is a bigger ratio of proton to neutrons, so protons are converted into the neutrons, and positron and the neutrino are released. So when those positrons, so positrons are at the same moment when they are produced, ejected from the uh, ejected from the atom. because of the high repulsion between the positron and protons inside the nucleus. So those positrons will be ejected from the atom. So in that case, that positron will traverse into the tissue. So these are traversing, but in doing so, these positrons will release energy. So is that energy is sensed by sensor. Okay, so this is sensor. So this sensor is made up of metal. Okay, so the electrons in this metal will get this energy and will energize. So when they will be energized, they will try to escape the metal. So they will do so. Electron, there is a flow of electron, and there could be a vacuum. There could be a vacuum. The electrons will travel through this vacuum, and here is a photomultiplier. This is photomultiplier. Okay, so this photomultiplier will convert this energy into an electrical signal, and that electrical signal could be displayed by the computer. So in positron emission tomography, is the strength of that signal is higher. That means some particular tissue are consuming more amount of glucose, and those tissues could be cancerous. So those organs or tissues, they should be further diagnosed, further recognized with other techniques, and of course must be treated if uh, those cells are forwarding to the malignant tissue. Okay, so this is the positron emission tomography. So this is actually the photoelectric effect. Next is the solar panel. Next is solar panel. In solar panel, actually, instead of some metal, we use the silicon. But silicon is the poor conductor of the electricity. But we want to transmit the electricity from the solar panel, and we say that we would use the material which is the uh, poorly conductive for electricity. But actually in the industry, these silicons, the p-type and n-type silicons, are manufactured in a way that this silicon can conduct the electricity, and as well they can produce the energy. But here is the photovoltaic effect. Okay, so now what happens, there are two types of silicon. This is p-type and this is n-type. N-type, because by mixing with this silicon phosphorus, we make it electrically charged, and by adding the boron in p-type silicon, we create the positivity. So in n-type there is higher negativity, and in the p-type the higher positivity. But One another important thing is added in this manufactured product, that here are the negative charged, okay, but at the border of the n-type signal there are positive charges, and in p-type, in the interior of the p-type silicon there are positive charge and there are holes in the p-type silicon, but at the border there is negative charge, okay. So at the border the situation is reversed in both the silicon types. So now if the sunlight fall on this n-type silicon, the electrons will gain the energy, and in doing so they will try to escape that place because they are energized, they want to run. But if they try to run from the n to p type directly, there is a barrier that is called pn barrier. However, actually it is np barrier, but in physics it goes. So these electrons when try to come from the n type to p type, here is a higher charge, higher negative charge. So this higher negative charge will repel those electrons. So in this way, those energized electrons cannot come to the p side directly because there is a barrier at the border. So electron now come to the wire, okay, energized, and this energy will be used for lightening some bulb or prepare the chapatis in houses, okay, and these electrons reverse to the p type. But the p type is sensitive to the sunlight, and these coming electrons are energized by the sunlight. So these electrons will jump to the n site. So the n site, which had been deficient for the electrons because the electrons had come out of this n type, so that deficiency is removed by jumping of these coming electrons from the n type to p type, from p type to n type. So this n type is again highly negatively charged. So again the sunlight is coming, that will fall on these electrons. Electrons will leave this n type, enter into the wire, will come to the p, and from p the jumping of those electrons from p to n type. So there is a continuous circuit of the electrons from n type to p type, and the energy is being consumed for our domestic tasks. So this is the photovoltaic effect, because here is a circuit completely, electrons are not leaving as was the case of as was the case earlier. Okay, so these are the explanations of these two seemingly similar techniques, but actually they are not. Thank you very much.